On October 19, 2024, as engineers combed through debris in the Gulf of Mexico, they made a discovery that would mark a turning point in space exploration. Among the recovered components of Super Heavy Booster 12 lay a single Raptor engine, number 314. But this wasn't just any engine. This particular piece of hardware was about to make history. For decades, the story of spaceflight has been one of remarkable achievements paired with staggering waste. Rockets built to be thrown away after a single use. SpaceX changed that narrative with the Falcon 9, proving that rockets could land themselves and fly again. But even that breakthrough wasn't enough for Elon Musk and his team. They set their sights on an even bolder vision. Starship, humanity's first fully reusable spacecraft. Now, just 6 flights into the Starship test program, SpaceX is about to cross another historic threshold. In a recent update about Flight 7, the company confirmed what eagle-eyed observers had already suspected. Raptor engine 314, recovered from Flight 5, will fly again. This marks the first time in history that a Starship engine will make a return journey to space. This isn't just about reusing a single engine. It's about proving that the most complex, high-stress components of the world's most powerful rocket can be recovered, refurbished, and relaunched. It's about transforming spaceflight from a series of one-way trips into a truly sustainable enterprise. Welcome to Elon Musk 24 Hours, bringing you the latest breakthroughs in space exploration. Today, we're diving deep into this groundbreaking development that's setting new standards in rocket reusability. Let's dive right in. The story of Raptor engine 314 begins in the pre-dawn hours of October 2024. As the massive Super Heavy Booster 12 thundered to life during Starship's 5th test flight, this particular engine was just one of 33 powerful Raptors pushing humanity's most ambitious spacecraft toward the stars. No one knew then that this engine would become a pioneer in spaceflight history. When Booster 12 separated from Starship and made its descent back to Earth, it carried with it the hopes of countless engineers who had spent years perfecting the recovery process. The successful retrieval of most of the booster's components from the Gulf of Mexico wasn't just a victory, it was validation of SpaceX's entire approach to spaceflight. But the real breakthrough came during the detailed inspection of the recovered hardware. Engineers discovered something remarkable about Engine 314. It had weathered the intense forces of launch and re-entry with minimal wear. The distinctive markings on its casing told a story of resilience, of metal and engineering pushed to their limits and emerging ready for more. When Elon Musk confirmed on X that Engine 314 would fly again on Starship Flight 7, he wasn't just announcing a technical achievement. He was declaring the dawn of a new era in space exploration. Just as the Falcon 9 revolutionized orbital launches, this moment marks the beginning of full reusability for the most powerful rocket ever built. The timing of Flight 7, scheduled for January 10th, carries its own significance. NASA has specifically requested this window to calibrate their tracking equipment in U.S. airspace before its deployment to Australia. This coordination between SpaceX and NASA highlights the growing synergy between private and public space enterprises, all working toward the common goal of making space more accessible. But the reuse of Raptor engine 314 is just one piece of a much larger puzzle. Flight 7 represents multiple breakthrough attempts converging in a single mission. SpaceX will make their second attempt at catching the Super Heavy booster using the launch tower, a maneuver that, if successful, would eliminate the need for ocean recoveries altogether. Picture it, a 230-foot-tall rocket, precisely guiding itself back to Earth, to be caught by mechanical arms like a cosmic game of catch. The engineering behind these achievements pushes the boundaries of what we thought possible. The Raptor engine itself represents the pinnacle of rocket propulsion technology. Unlike traditional rocket engines, which often waste significant portions of their propellant, the Raptor's full-flow stage combustion system is a marvel of efficiency. Every molecule of fuel and oxidizer passes through the engine's twin pre-burners before entering the main combustion chamber, extracting maximum performance from each drop of propellant. SpaceX's development of the SX500 superalloy specifically for the Raptor engine exemplifies their innovative approach. This proprietary blend of copper, aluminum, and steel can withstand pressures up to 12,000 psi and temperatures that would melt conventional materials. When you consider that each Raptor engine generates more power than a dozen Hoover dams, the importance of these materials becomes clear. The journey to this point hasn't been without setbacks. March's challenging moment during Starship's third launch, when a restart attempt was aborted after the rocket lost control, served as a crucial learning experience. The engineering team's response, methodically analyzing the failure, implementing improvements, and validating their solutions through rigorous testing, demonstrates the iterative approach that has become SpaceX's hallmark. Looking ahead to Raptor 5.3, currently under development, we see SpaceX's commitment to continuous improvement. While V2 engines like 314 have proven their reliability, serving as the foundation for Starship's early flights, V3 promises even greater performance and reusability. The decision to reuse V2 engines now, rather than waiting for V3's completion, reflects a practical balance between immediate progress and long-term goals. The implications of successful engine reuse extend far beyond SpaceX's bottom line. When you consider that each Raptor engine costs millions to produce, the ability to reuse these complex machines multiple times drastically reduces the cost per launch. This isn't just about saving money, it's about making space accessible to a broader range of missions and possibilities. Think about what this means for future Mars missions. A fully reusable Starship, capable of making multiple trips with minimal refurbishment, could establish regular cargo runs between Earth and Mars. The same engines that lift off from Earth could potentially fire up again on the Red Planet, using locally produced methane fuel for the return journey. Think about what this means for future Mars missions. A fully reusable Starship, capable of making multiple trips with minimal refurbishment, could establish regular cargo runs between Earth and Mars. The same engines that lift off from Earth could potentially fire up again on the Red Planet, using locally produced methane fuel for the return journey. SpaceX's manufacturing innovations further support this vision of sustainable spaceflight. The shift away from traditional threaded fasteners in favor of welded interfaces might seem like a small detail, but it represents a fundamental rethinking of how we build spacecraft. Every welded joint eliminates potential points of failure while reducing assembly time and cost. Even their selective use of 3D printing shows a pragmatic approach to balancing cutting-edge technology with production efficiency. The environmental implications of Raptor's design choices shouldn't be overlooked. The decision to use methane as fuel rather than traditional rocket propellants results in cleaner combustion with fewer particulate emissions. When burned in the Raptor's highly efficient combustion chamber, the only byproducts are carbon dioxide and water vapor. While no rocket is truly green, these design choices minimize environmental impact while maximizing performance. As we approach Flight 7's launch date, the space industry watches with intense interest. Success would validate SpaceX's strategy of rapid iteration and testing, while demonstrating that even the most complex components of a rocket can be made truly reusable. Failure would provide valuable data for further improvements, continuing the cycle of innovation that has brought us this far. The future work environment in mission control during Flight 7 will be charged with both excitement and focused determination. Engineers will monitor Engine 314's performance with particular attention, comparing its metrics against both its previous flight and its peer engines. Every successful milestone, ignition, ascent, stage separation, landing, will bring us one step closer to the goal of routine, reliable space access. We're witnessing the culmination of decades of rocket science, materials engineering, and computational modeling, all converging in a single engine that refuses to be disposable. Engine 314's second flight represents more than just a technical achievement. It's proof that the dream of fully reusable spaceflight is within our grasp. The impact of this achievement will ripple through the entire space industry. Just as the Falcon 9's successful landing sparked a global race toward reusability, the reuse of Starship's engines will set new expectations for what's possible in space exploration. We're not just watching technological progress, we're witnessing the foundations being laid for humanity's expansion into the solar system. When Engine 314 ignites for its second flight into space, It will carry with it the accumulated knowledge of thousands of engineers, the dreams of space enthusiasts worldwide, and the potential to fundamentally change how we access space. Every successful reuse brings us closer to the day when space travel becomes as routine as air travel, when missions to Mars are regular occurrences, and when the stars themselves seem just a little bit closer. When Engine 314 ignites for its second flight into space, it will carry with it the accumulated knowledge of thousands of engineers, the dreams of space enthusiasts worldwide, and the potential to fundamentally change how we access space. Every successful reuse brings us closer to the day when space travel becomes as routine as air travel, when missions to Mars are regular occurrences, and when the stars themselves seem just a little bit closer. As Engine 314 prepares for its historic second flight, we're standing at the threshold of a new chapter in space exploration. This isn't just about reusing a single engine. It's about proving that even the most complex components of humanity's most powerful rocket can be recovered, refurbished, and relaunched reliably. The success of Flight 7 will demonstrate that SpaceX's vision of rapid, reusable spaceflight isn't just a dream, it's becoming reality. Each milestone brings us closer to regular Mars missions, sustainable space travel, and a future where the stars are within humanity's reach. We'll be here to bring you every development as this remarkable story unfolds. Will Engine 314 perform as flawlessly on its second flight as it did on its first? How will this achievement reshape the future of space exploration? Share your thoughts in the comments below. If you want to stay updated on the latest developments in space technology and SpaceX's journey to revolutionize space travel, make sure to subscribe to Elon Musk 24 Hours. Hit that like button if you found this deep dive into rocket engine technology fascinating, and don't forget to turn on notifications to catch our coverage of Starship Flight 7 as it happens. See you in the next video, where we'll continue exploring the frontiers of space technology together. The next giant leap inside SpaceX's Starship 5, standing 394 feet tall against the Texas sky, Starship isn't just the most powerful rocket ever built, it's humanity's next home among the stars. While its gleaming steel exterior has captivated millions, the true revolution lies within its walls. Through 6 groundbreaking test flights, SpaceX has been quietly transforming Starship's interior. Gone are the days of Ship 16's rough surfaces and exposed framework. Today's Starship represents something far more refined, more capable, and more human. The evolution is striking. Early prototypes featured intricate lattice frameworks spiraling through their nose cones. Necessary, but space-consuming. Now those same areas reveal sleek, finished compartments with minimal support structures. This isn't just about aesthetics. It's about creating a vessel that can truly sustain life beyond Earth. With over 50 meters of height and a 9-meter diameter, Starship doesn't just carry cargo, it offers a glimpse into how we'll live and work in space. From hydroponic gardens to observation lounges, from private quarters to research labs, every cubic meter has been reimagined for the next chapter of human exploration. Welcome to Elon Musk 24 Hours. Let's dive right in. The journey through Starship's interior begins where every space adventure starts, at ground level. As we step inside this marvel of engineering, we're entering more than just a rocket. We're walking into humanity's first interplanetary home. The lower section houses Starship's beating heart, up to 9 Raptor engines, each a masterpiece of propulsion technology. But what makes this spacecraft truly revolutionary isn't just its raw power. It's how SpaceX has transformed every cubic meter above those engines into a carefully crafted environment for both cargo and crew. Picture yourself ascending through 6 distinct levels, each designed with the precision of a Swiss watch and the comfort of a modern living space. The cargo deck sits at the foundation, a cavernous space that could swallow a small house whole. This isn't just storage, it's the seed from which future colonies will grow. Here, robots and rovers await their chance to roll onto alien soil. Scientific instruments stand ready to unlock the mysteries of other worlds. The electrical systems that will power humanity's next giant leap hum quietly in their housings. But SpaceX knows that space exploration isn't just about machines. As we move up to the second level, we discover something unprecedented in spacecraft design: a garden. Not just any garden, but a sophisticated hydroponic system where future astronauts will nurture their own fresh food. The psychological impact of tending to